Welcome back to Archaeology After Dark, everyone. I'm, of course, your host, Daniel Rhodes. My guest today is Iride Tomazic. I swear I had it before we started recording. I'm so sorry.
It's okay. It's close. It's close enough. Do you want me to try to pronounce it properly or?
Yes, please, please, so I don't have to try again.
It's Iride Tomazic. Yes.
So tell us a little bit about yourself.
I am a graduate student at the University of Michigan. Um, Currently going into my 8th year. Sounds awful. But yeah, I'm working here for now, and hopefully next year I'll graduate, and then we'll see. I am so for my dissertation, I'm running a project called Dangerous Technologies, which is trying to analyze basically how does the intensification of metallurgical production impact people, animals, and the environment. And I'm basically using what we would know from like public health kind of methods and environmental methods in archaeology.
So you've been doing this for a while. How do you see the connection between metallurgy and the way we look at public health now?
It's interesting because it's like, so public health, like explored for a really long time, like from actually like some of the studies actually historical. So like, for example, with the Industrial Revolution, that was like one of the first studies that kind of like realized that, oh, these toxic elements like lead, arsenic, and similar impact people health and leave like long-term consequences on the environment, on like people, like even genetical signatures for generations. And my idea was like the first technology that we know produces such elements is metallurgy. So I started like investigating this. The idea itself actually started in 2014 when I did my master's, and it kind of like continued to develop like through the PhD.
So you're looking at how like certain kinds of metals like arsenic and things like that, after they've been in the ground for so long or in the environment for so long, how they affect people and animals.
Yeah, that's that as well, but primarily I'm looking at like kind of like at the process when people actually do smelting. So like when society started doing metallurgy, they extracted the ore, they started smelling it, and when the ore contacted like fire, so it kind of like started smelting, the heavy metals and their particles kind of went into the environment. People inhaled it, it went into the ground. Plants absorbed it, animals absorbed it, like ate it, and so there are like different ways of how you can come in contact, and all of this, it's going to impact your health, it's going to impact how you see the environment, it's going to impact like again, metallurgy, it's not the most like nice smelling kind of technology, so it's stinky. So my idea was like, oh, do you really want to have like something stinky in your backyard, or you don't really care? So like the idea was like kind of like trying to understand how this heavy, like how this like technology basically impacted. Like, did people know that this was impacting them? They didn't care maybe? Like that's the kind of like how I went about this. Yeah.
Yeah, and I think that's something people don't, think about when they, make something like the Industrial Revolution just introduced hundreds of different things into like just creation in general. Like when they made something, they didn't realize at the time the consequences that came along with it. Like using arsenic or lead when you make something is toxic now. It's really toxic.
No, exactly. And like this kind of like concept of toxicity, I think it's more something that we understand today. Like if you think about it, like even in the Victorian era, they were using arsenic in their like beauty products. Or like Romans were putting lead into their wine to sweeten the wine. So like I don't think that this was like a concept that they actually understood until it was too late. So like for example, there are pictures of like the like Greeks and like the Greek god of metallurgy being all crippled or like kind of like all crouched. So like maybe this is something that was a knowledge back in the day from society to society, and not something that was like a widely spread. Or maybe it was. Hard to know.
Yeah, and arsenic is something they've used as a color for hundreds of years. Like there's the story of I want to say it's a dress that they dyed in arsenic, and when they got sweaty in the dress, it actually soaked into the skin and then killed like six people. It's pretty tragic. It's a really nice dress, but it's a really tragic story.
Well, but that's the thing. It's like I think that's like exactly how you said it, right? Like people didn't maybe understood, didn't see it this way, maybe, And there is actually I learned what was like a couple of months ago that there is, like the way even artifacts were curated, archaeological artifacts, they were like treated with arsenic glue and like similar kind of like, toxic elements that today we know it's not okay to touch. But back in the day, it was like, it was something that was normally used. So toxicity is definitely something that I think like we understand a little bit more today than it was in the past. Yeah.
Well, I guess that's partially because, the health standards have improved so much. Like back in, the Greek and Roman times, they didn't actually have like a universal standard of healthcare or like these are the things that we know to avoid. They just did it and chose to live with the consequences.
Well, it's also, like I think it's also like the DNA, for example, like DNA and this kind of like medicine, like preventative medicine primarily. And like as you know, like in the US with like when, the lead crisis with the paints, right? When children were eating paint that was contaminated basically with lead, it's something that we have like I think more knowledge, and like by having more knowledge we can make more correlations. And I think that's where something that was maybe not something that was a wider knowledge at the time, or it was, but it wasn't like it was kind of like, so it was maybe like so obvious that they were like, yeah, this is what it does, but we don't kind of like really see the correlation, so whatever.
Yeah, I mean, it's one of those things that since they didn't have a cure for it, they just kind of had to live with it. Like, oh, got the lead poisoning. This, well, what are
That's
you
how
gonna do?
it is. Yeah.
Yeah, it sucks, but there's not a whole lot we can do.
No, exactly. I mean, it's like even today, to be honest. I mean, today there are like preventative measures when you get like kind of like what is called like like a metal disease, when kind of like your guts get basically overwhelmed, and then you get like similar medicine that basically extracts this and processes through the body. Um, but like, some of these consequences are long term. Um, like the fact like the DNA, like the DNA breaks cause mutation. I don't think we fully understand.
Well, I mean, understanding is the whole reason we study things like this to begin with. So we find out that it's, bad for us or dangerous. We can figure out a way to not use it.
Yeah, I mean that's the golden standard, right? Like it just don't, if you don't know what it does, just don't do it.
Well, I mean, I feel like that's like counterproductive to science. So like, oh, we don't know what it does, so let's test it out, and you end up with things like again lead poisoning, which isn't great.
Yeah, I mean there were some studies done in public health on primarily mice experiments, which is again, we can debate about this all we want, but there was a study done on arsenic poisoning. So what does arsenic do like for multiple generations? Like for female mice versus male mice, and how does that impact them in terms of like genetic mutation and all of that. So there is a lot of like work doing in this kind of sciences, and even like geology, for example, like there are studies where through cores you can identify periods back in time when there were like peaks of pollution, right? Like so the very first one actually dates to the Bronze Age, so like around 2000 BC. And then you have a couple of other spikes like during the Roman Empire, primarily during the time when um, when like there was like the kind of like expansion of the empire, and then you have the other peak in the medieval, and then kind of like industrial revolution, and then today it's like up here. So it's interesting how people do that.
Yeah, and interesting that you point out those specific periods because those are when people, actively were trying to learn about the things around them. Like they were trying new techniques, new materials, and things like that. And, you know, the pollution, I guess, is an end result of trying things out. Like we talked about, like you don't necessarily need to experiment to know it's not good for you.
And again, like I think, I don't think it's just a period of trying. I think that's the period when we do a lot of it, right? Like that's when you're gonna really see it in the environment. When you're trying, like the kind of trying and error, that's gonna kind of produce like low levels. But when it becomes a lot, right? Like during the Industrial Revolution, like we know that there was a lot of factors, right? And it just like things went out of control. And that's where you kind of like see it really in the environment. So this kind of like nuance, like lower periods are almost kind of like a little bit buried. So, for example, like that's something that I'm trying to understand, like because like in the area where I work, so I work in the Southern Carpathian Basin, where ores are not, all ores are actually coming to settlements. They're not like any close by. So like they're always kind of bring them intentionally. And they really develop metallurgy, like localized metallurgy, so that they do it like in their settlements kind of later than other parts of the Balkans, for example. And a lot of the time, this kind of like signal, it's a little bit, it's not as strong. So we know that they're doing it, but we don't really have a lot of evidence that they are doing it. Only when you get like to the kind of like, you know, really high intensity times, like around 2200 BC, that's when you kind of like everybody does it. You see it, you see evidence for it. So kind of understanding these nuances, I think it's also really important.
So, how do you go about gathering evidence to support the narrative you're trying to tell people? Because it's not like you can just go around gathering toxic substances. Well, you can, you shouldn't, but you can. I'm disclaimer for this episode: please don't go gathering toxic substances. It's a horrible idea. Don't do that.
Yeah, don't try this at home. Uh, but the idea is, so like I kind of use like multiple lines of evidence. So I'm using basically what we know from the archaeological record, if there was like metallurgy produced or wasn't, and in what way. So do we see artifacts? Do we see any kind of like burning? Do we see ovens? Do we see slag? So like, do we see any kind of residual metallurgy? And then the second line of evidence that I'm using, it's basically animal teeth, because animals, first of all, animals that are domestic and wild, that kind of like helps us understand how it impacts like the closer community, but also the wider community and like, the wider environment. And in particular, I'm using teeth for this, for a couple of reasons. The first reason it's because I thought when I constructed this that I'm going to find like a lot of animal like teeth remains. Well, that was not the case. um, it's actually surprising. Like certain societies are extremely clean, so like you don't see like you see some bones here and there, but not a lot. So that was kind of like a kind of kind of moment. Um, but that was the main idea, and also like because like again they don't bury people into the settlement, so people are usually buried in cemeteries. um and teeth are actually they're really strong, so they're like really um the they're almost like tree rings when you cut them, so you can actually tell by day the amount of like elements or trace elements, what we call, so like calcium, strontium, and other elements that compose this tooth, and it kind of creates almost like a life history that you can go back and kind of understand both chemically and morphologically. And then I also use soils because certain elements are not in the teeth, so like they don't get incorporated in the teeth. So I'm using like sediments as like another component, basically.
So what you're saying is if you're looking at like a tooth from like a pig or a goat or something like that, the
Mhm.
elements or the periods of higher toxic exposure will stand out while you're looking at it.
Yeah, because so there are a couple of elements that kind of like interact with each other. One of them are like one kind of relation that is well known in public health is the relation between lead and calcium. So calcium tends to, like lead tends to replace calcium in the, like in bones and teeth. And what it happens when this happens, you can see like in the tooth itself, you can see like high spikes of lead. And like, and if you look at calcium, you see the kind of like almost like black stripes in it. So both chemically and like visually, you can actually see that.
So how do you go about displaying the results that you've put together? Is it like how do you do it? I mean, aside from, giving a presentation or a poster.
Well, I'm trying. So one thing that I'm currently trying is presenting the results in on Instagram and like trying to like I'm trying to kind of like say that like there are archaeology is like it's such an important to like such an important science because we can look at like the past for such a long time, but like we can look at different places, as you know. So what I'm trying to do is kind of like show that we can actually contribute to questions like this, right? Like by like, through the Instagram, but also like talking to people. I also created a presentation for students here for students, for children and like adults at a museum and the Natural History Museum here in Ann Arbor, and trying to kind of like show them that archaeology can actually contribute to this kind of debates. And I still think that this is like something where we can, because there is so much that we can investigate and there is so much that we can contribute that I think if we kind of like just stop within our scientific world, like putting down your face and just like work on your sampling or work on different stuff, you don't really get to explain this to people. And I think that's the kind of like value, right, in the end of what we're doing.
Yeah. And, what you're talking about doing is a great way to show how archaeology can actually, as a practice, can be used to solve, like, or contribute to, like, the problems we have now of, like, healthcare or environmental health or something like that. We can
Right.
use, the things we find in the past to now.
No, exactly. And the thing is that um it's almost kind of like an experiment, right? Like a lot of this kind of like sciences, like public health and geology, they have this kind of like, so public health can work only with like current populations, right? So current populations, like they're like usually the sample size is a little bit smaller, but we can kind of like go big, right? You can look at like the long period, you can look at multiple places at the same time. And it really kind of like has this almost like movie, like a kind of like a movie component, right? When you can kind of project, like, and see how in the past, okay, this happened. How did people react to this? And then go on another place, how this happened. So how did these people react to it, right? So I think like it offers us not only the long durée, but it also offers us the opportunity of looking how different societies react to like the same kind of like technological advancement, like for example, like metallurgy, right? So I think that's like a really important thing how archaeology can really contribute to this kind of questions. Yes.
So, for people who are watching this episode, students or anybody who's interested in learning more about what you do or would like to get involved in archaeology or just any advice you'd like to toss out, what would you recommend?
So I would definitely, so there are numerous ways how you can get involved. So like I'm originally from Slovenia. So for example, in Europe, it was easier to get involved into commercial archaeology or CRM. I'm not familiar how the situation is here, but my biggest advice would be like, if you're interested in this concept, just try it out. try different things. Like try to get like contact people. Don't be afraid of sending emails. Like sometimes you're gonna send 200 emails and you're gonna get only 5 responses. But those 5 responses can get you, anywhere. So I think being persistent, being flexible, but also don't accept no as an answer.
Yeah, taking no for an answer is not a great way to get involved in really anything. So to a point, after so many no's, you need to just kind of move on because there is a such thing as boundaries, and you do need to respect them when you're talking to other people. But just making sure that you're committed to something is a great thing to have in archaeology.
Yeah, definitely. And also, like, for a lot of like undergraduate students, for example, here in Michigan, I tend to mentor like not just like archaeology students, but also interdisciplinary students. And the advice that I give to my archaeology students, it's like just try as many things as you can. Like try to like excavate in different places, different type of like societies, get involved into lab, and like not everybody's going to be a field archaeologist, nobody's going to be a lab archaeologist. Like you have to try different things to figure out what is your niche, what do you really like to do. And honestly, I think like sometimes like we get so bogged down into the details and trying to pursue like one single road, but it honestly like it can vary a lot, right? Like I, for example, I didn't expect that I'm going to do chemistry stuff at all when I started this. But the kind of COVID and everything brought me into this kind of way. So I think, you know, be open-minded and try things out.
Yeah, that's a great way to approach really just about anything. You won't know if you are bad at something until you try it. And if you find out you're bad at something, don't hold it against yourself because you have time to learn and be not so bad at it.
Well, but like again, like even if you're and like I think that was like one thing for me when I started this process. Like I thought like I was so bad at all of, all of the chemistry stuff. And I remember as like had like my first experiments, and like I had like one failure after the other, and I was like, what is going on, right? And you kind of like start bogging yourself, and like as a PhD student, you don't have much time. And I was like, oh man, I should just like maybe like switch. Like, I don't know what is happening. But then I realized that it was like, on one day that like when the experiments failed, we had like there was a problem in the electricity. So it like that caused like a failure within the machine. So all of the samples got bad. But because like I didn't have like a lot of knowledge how the actual machine worked at the time, I had no idea that that's what caused it. So like there was a lot of like trial and error as well in this whole thing. And I think like a lot of the times we don't emphasize the errors enough because like I think those are really important like lessons. And that's definitely something that I think it's been a really important thing to learn in the PhD. The list of errors is very long and the list of successes is very small.
I mean, that's the fun of science, though. It's trial and
It
error,
is.
and again, avoiding the toxic substances. And if you're going to do chemistry, don't start any fires. Those are hard to explain when people ask you what happened.
Or don't, like there are a couple of things that you should always do, like doing your course requirements, like don't like go into the lab without your PPE, like all of this don't, touch things and put things in your mouth. Like there are a lot of no-nos in the lab.
Now, see, it's funny that we, don't know to do these things, but we still end up having to tell people don't do them because they're going to do them anyway.
Yeah. And it's like, and it's like the amount of times that you see things, and I think that I actually had this conversation with a professor of mine. And it's interesting because like when you're learning something, you're so focused on what you're doing and you're kind of like really careful, like every single thing, how you're gonna do it, like step A, B, C, D, you're so careful. But then once you get comfortable with it, that's when people become sloppy. And it's like, and that's where kind of you start cutting corners and all of that. So it's like you always kind of have to keep that reminder in your mind that it's like, I'm trying to do this properly and I'm trying to do it only once. if I'm going to become sloppy with how I'm doing things, I'll have to repeat this multiple times. And I don't have the time, the nerves, or the money.
Okay, I'm gonna try this one more time. Eared. No. Say it for
It's
me one more time.
it's like the word iridium
Mm-hmm.
or iridescence. So iride.
Irida.
Yeah, close enough.
Yes, I'll take it. Okay. It's been an absolute joy having you on the show today. That's going to do it for us here at Archaeology After Dark. So I don't butcher her name again. That's really embarrassing. I'll work on that, I promise. But thank you so much for joining me. This has been a lot of fun.
Thank you. Thank you for the invitation.
That's going to do it for us, everybody. See you next time.
See you.